Hello my dear students, welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about the NQ algorithm, that is how to perform the insertion operation. Well, in today's video we will discuss about the DQ algorithm, that is how to delete the elements from the queue. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end, do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. So this is what the complete algorithm of DQ. So we have the array which is already filled with items. So just assume that we have inserted the element into the queue and we have done with the NQ operation. So when we have done with the NQ operation, the front will be pointing to 0 and the rear will be pointing to queue size minus 1. So for example, if the queue size is equal to 5, so n minus 1. So queue size means n value. Queue size minus 1 means 5 minus 1. So it is pointing to 4. So front is pointing to 0. I'm just telling you the index value, that is 0. Q of 0. The array name is Q of 0, so it is pointing to the front position. Q of 4, it is pointing to the rear position. So front is 0 and rear is 4. So when we start the DQ operation, the first condition that what we need to check that whether we have the elements in the queue or not. So if there are no elements in the queue, then what to DQ? So we need to check a condition here where if the front equals to minus 1. So when the deletion operation takes place, we do the incrementation of the front pointer. And after the incrementation, when it reaches to the last element, it will be the last element means we have to DQ that last element and we need to reset the pointer, that is both front and rear, to minus 1. So in such case, the front will be pointing to minus 1. So front will be moving forward and we will DQ the elements, that is first in, first out ordering principle wise, we will DQ the elements. When the front reaches the last element, we will DQ that and we will reset the pointer to minus 1. So if that is the case, front will be minus 1. So if front is minus 1 means it says there are no elements in the queue. But right now in this situation, in this case, front is 0 and rear is 4. So I need to check the condition here. Is front equal to minus 1? So what is front value? It is 0. Is 0 equal to minus 1? No. Condition not satisfied means to say there is no underflow, means elements are available in the queue. If there are no elements, then front will be minus 1. Then I will be getting the message the queue is underflow, queue is empty. Right? But now the queue is not empty, the queue is filled with elements. Now I'll come to step 2. I just say item equal to Q of, that is front position. Front means 0. What is Q of 0? It is 10. I am simply storing this element into the item, that is temporary variable item, so that I can put a message to the user saying that this item has been DQ'd. So this item will be removed. It will come out. Right? Then step 3. If front equal to rear, if front equals to rear, as I said, when front pointer, rear pointer will be the same, then that will be my last element. This is to check with the last element. If this is the last element, then I need to reset the pointers. Front and rear will be set to minus 1. Is front equal to rear? What is front value? 0. What is rear value? 4. Is 0 equal to 4? No. Condition, that is 0 which is front value and 4 which is rear value. Is this condition true? No. If this condition evaluates as true, then I need to reset the pointer. But right now the condition is false. I'll come to else part. When I come to else part, as the first item is DQ'd, I need to move the pointer to the next position. I'll come to else part. I'll say front equal to front plus 1. So just say front equal to front plus 1. 0 plus 1 means what is the front value? It is 1. Now the front is pointing to this position. Then again return, get back. The next iteration, what happens? I just check is front equal to minus 1. Front is 1. 1 equal to minus 1. Again condition not satisfied. Then I need to transfer that element into the temporary variable item. I just say q equal to, which is front, q of 1. So what is q of 1? Q of 1 is 20. So 20 will be stored in this temporary variable, and I put a message saying the user that this particular item has been dequeued. So 20 will be removed. Then again front equal to rear. What is front? It is 1. 1 equal to 4. Condition not satisfied. Then I will come to else part. I say front equal to front plus 1. Front equal to 1 plus 1. It is 2. Now the front is pointing to 2. Index 2. So it is index 2. Then again I just say return. Go back. Then I say it is 2 equal to minus 1, front equal to minus 1, no condition not satisfied. Then I say item equal to q of 2. So what is q of 2? It is 30. So 30 will be stored and it will be dequeued. Acknowledgement message to the user saying that 30 is dequeued. Then again front equal to rear. What is front? It is 2. 2 equal to 4. Condition not satisfied. I'll come to else part. I say front equal to front plus 1. What is front? It is 2. 2 plus 1, it is 3. Now front is pointing to the next position, which is 3. Right? Then again return. Now check. Go back to the step 1. Front value is 3. Is 3 equal to minus 1? Again condition not satisfied. Then I need to transfer that element into the temporary variable item. Item equal to q of how much? Front value means 3. What is front? It is 3. Q of 3, it is 40. 40 will be stored and it will be dequeued. Then again check the condition is 3 equal to 4. That is front equal to rear. Again condition not satisfied. Come to else part. I say front equal to front plus 1. 3 plus 1, which is 4. Now front is pointing to this. Both front and rear are equal. Let me write the next iteration here. So I'll go back to the step 1. Front is pointing to 4. As front means 4 equal to minus 1. Condition not satisfied. I'll say item equal to q of how much? It is 4. What is q of 4? It is 50. 50 will be dequeued. So acknowledgement message to the user saying that 50 is dequeued. Then now here comes the point. Is front equal to rear? What is front value? It is 4. What is rear value? It is 4. See, both front and rear pointing to the same position, 4. 4 equal to 4? Yes. Now the condition is satisfied. When both front pointer and rear pointer points to the same position, it means to say it was the last item that what we have dequeued and it's time to reset the pointers. So here condition gets satisfied. These two statements gets executed. Front becomes minus 1 and rear also becomes minus 1. Front equal to minus 1 and rear equal to minus 1. Do we have to come to the else part? No. This condition is true. So these two statements got executed. Again say return. When I get back to the return position, here comes, see, front and rear is reset to 1. So the pointers are like this. Front and rear both are equal to minus 1. The pointers are reset. Now come to this position. Is front equal to minus 1? Yes, of course. Minus 1 equal to minus 1. Condition is true now. Then I get a message Q underflow. See, the Q is empty. There are no elements to dequeue. So this is how the dequeue operation takes place. You have to write down these iterations by yourself and solve it by yourself. Then only you can analyze this complete algorithm. So hope you have understood with this dequeue algorithm. In the next video, we will discuss about the enqueue and dequeue program. That's all for today's video. See you in the next video. Till then, take care. Bye-bye.